space futurist. He's a TEDx speaker, LinkedIn learning instructor, and former IBMer. He writes and speaks on emerging technologies, including AI, quantum, crypto assets, blockchain, augmented, and virtual reality and robotics. And I'm very close with the IBM director in the Almaden Labs. We have been talking about some of these topics, for example. I think you can go ahead and start introducing and take over.
Okay, great. Thank you, KRS, and good morning, good afternoon, good evening, everybody. Delighted to be here. As you said, my name is Christopher Bishop, and I'm a technology futurist and a TEDx speaker and a former IBMer. I'm excited to be hosting this terrific panel. Looking forward to a lively conversation about how these two leading technologies, AI and quantum, will positively impact both society and business. So I'm excited that we're going to be talking about a range of topics here. We have terrific guests on the panel. We have Terrill Frantz, who's a professor of e-business and cybersecurity and quantum information science at Harrisburg University. Denise Ruffner is joining us. She's the chief business officer at Cambridge Quantum Computing. They had an amazing announcement today. We're going to weave that into the conversation, share that with you. Chris Papile is the CEO of BraneCell. He's up very late. He's in Dusseldorf, Germany. It's like 1:30 in the morning for him. So thank you in advance, Chris, for joining us. And then Chris Fregly, who's a developer advocate, AI and machine learning at Amazon Web Services. So delighted to have them all here. Just to orient you in terms of format, I've asked each of the panelists to share some insight into who they are and what they're doing, what they're currently up to in this space. Then I've put together a series of questions that are designed to tease out more insight and detail around both the current state as well as what might lie ahead for AI and quantum. And then finally, we're going to use the last, say, 15 minutes or so to answer your questions. So please be thinking about what you want to ask our panelists and post your questions in the Q&A client here in Zoom. So thanks again for joining us. Let's begin with Denise. So Denise, I'm going to pull up charts for you, right? Let's share my screen. Here we go. See if we can make this work. Screen one. Is it sharing the right content?
Yeah, thank you, Chris.
Yeah.
Yes, we can see.
You can see, okay, great. And is my audio okay? Can you hear me all right?
Yeah, perfectly okay.
Okay, great. So Denise, I'll turn it over to you. Please share what's happening at Cambridge Quantum Computing.
Sure. Hi, everyone. Nice to be here. Thank you for sticking with us. I don't know what time zone most people are in. I live in the Los Angeles area, so I'm in the Pacific time zone, and I guess I'm lucky enough not to be with Chris in Germany at 1:30 in the morning. So thanks again, Chris.
Yeah, no problem.
So I'm the Chief Business Officer at Cambridge Quantum Computing, and came to Cambridge Quantum Computing from the IBM Quantum team. So I can talk a little bit about from things from both a hardware perspective from IBM as well as a software perspective from Cambridge Quantum Computing. So if we go to the next slide, before I get to the announcement, I'm going to tell you a little bit about our company. So a lot of people confuse us and say, Cambridge, oh, you're in Boston or in Massachusetts. No, we're Cambridge, UK, but we do have offices in Japan and in the US. And what we do is we are a global provider and/or developer of quantum software. So we're one of those companies that are trying to develop software packages that can run on quantum computers and provide the end user with innovation, perhaps without having to be quantum physicists, as well as some quantum security solutions, which I'll talk about in the next slide. What's interesting is we are one of the older quantum computing companies. So we were started in 2014, which is considered very old. We're 6 years old. We have about 100 employees worldwide, and the majority of them are scientists. So we've been very much of a science-first company. We spent the first probably 5 years trying to just develop our IP and develop our expertise So we have this just great staff of scientists, and we've attracted a lot of Fortune 100 customers. I think what's really interesting is that both Honeywell and IBM Quantum have invested in us. And so we're the only startup company that has basically access to any of the IBM devices as well as the Honeywell devices. And we do work with Honeywell on their new devices. So we have insight into what's coming next, and we actually get to play with it. So it's quite exciting. So as I said earlier, our areas of focus in software, we've done a quantum development platform we call Ticket. And what Ticket is a device agnostic platform. So it allows you to write your code on top of Ticket and then move it from platform to platform, which is important because a lot of people need to rewrite their software if they want to go, let's say, from Rigetti to IBM. But using Ticket, all they do is change one line in the code, they can move it. We also are working on enterprise software packages for chemistry, quantum chemistry, as well as in quantum machine learning, hence the invitation, as well as quantum finance. What I want to talk about now is an announcement that we made on quantum cybersecurity that we're really excited about. So Chris, if you can go to the next slide.
Yeah.
So in partnership with IBM, and it's important to note, IBM has just been a great partner for us. We've launched a beta, which is the first cloud-based quantum random number generation service. Now, what's unique about this is really the fact that not only can we generate random numbers, but we've written code so that we can actually test and verify that these numbers, or certify even, that these numbers are truly random. And this is unique. No one's been able to do it. And what's also great about this is we believe that this could be one of the first applications of a quantum computer. So what is quantum randomness? It's a raw material in a lot of digital interactions in encryption and in simulation. And so we're just very excited that we can now do something on a quantum computer that can't be done on a classical computer, and really has a lot of different applications in cryptography, in simulation, in a lot of different industries. And we're excited to be doing this in partnership with the IBM Quantum team. And it's available to members of the IBM Q network. And the IBM Quantum team just had a summit over the past 3 days where we introduced this work, which was validated by IBM. And we also trained everybody on how they can access these random numbers and get this information. So it's a very exciting announcement. So Chris, back to you. Chris?
Sorry, I'm on mute. I put the link to the press release in the chat client. So everyone, please take a look. It's a very exciting announcement. As Denise was saying, it's a real breakthrough moment. So it portends lots of an increased advancement in the application of quantum writ large in the real world. And we'll talk a little bit more about that when we get into the Q&A section after the presentation. So thank you, Denise. Chris Papile, let me turn it over to you. Let me get your charts up, right? I'm going to stop sharing this screen and go to the other set of charts, which are in here. Here we go.
Chris Papile, you look pretty good for 1:30 in the morning. You go.
Really, man?
Thank you so much,
impressed.
Denise. That's very kind of you. It was a wonderful description of your work, and it was very impressive what you all are doing there at Cambridge Quantum Computing. Thanks all for that. And thank you, Chris, as well. I thought about doing this presentation in my pajamas just to make a statement, but I decided just to keep it normal as possible. So, yeah, that's BraneCell's cover page. the starlings do this murmuration where everything moves in coordination, and that has actually an important point to what I'd like to make in this presentation about BraneCell. If you could go to the next slide, please, Chris. So BraneCell is primarily a hardware company, even though today I would like to talk about quantum machine learning and AI and quantum processing. But just to mention here about our company, so we are developing a photonic-based quantum processing unit and also a quantum repeater, because they use the same basis of qubit, which is unique and very helpful because that enables a seamless connection between quantum processing units between each other, bridged by repeaters. And that's going to be very helpful in, quantum high performance embedded computing, high performance quantum computing that's embedded to help us in a lot of important tasks, a lot of important applications, which I'll speak about a little bit later. So another advantage here is that when we want to try to use it in AI, quantum processing capabilities, you're going to need to have some pretty fast and ability to handle a lot of incoming information. So we believe that our processor will be quite faster and smaller, so it'll be able to be used on location, hopefully in the future. Of course, we're not doing that yet. And it's not going to be needed to be at liquid helium temperatures. There's a lot of advantages to enable some very important applications, actually the majority of applications in the world. So that's what we're going after. And our company actually has been around since 2015, so not as long as Cayman's quantum computing, but quite some time. And again, also developing our intellectual property portfolio and team and so forth. Next slide, please, Chris. So we have funding from the Department of Defense, U.S. Department of Defense, Department of Energy. We work with West Virginia University and on multiple departments there and professors, and also a company called Allegheny Science and Technology. But really what's important here is because it takes some time to develop quantum computing hardware, we're already engaged in projects related to wind and solar based chemical production or hydrogen production, because wind and solar have a really difficult control system. So you have to do a new style of controls that we didn't need to do before in chemical applications. So we find this to be an excellent application for quantum computing and perhaps AI together with quantum repeaters. Next, please, Chris. And this slide is just emphasizing what I just said. Our company is already engaged in projects, and as Denise mentioned, some of her clients, we are already working in the Middle East with clients on topic matters for control systems for renewable hydrogen, as mentioned earlier, and things such as anomaly flags, which quantum computing and quantum algorithms are very good at. And I'm going to hopefully get an opportunity to speak a little bit more about AI and quantum machine learning and how it all comes together with quantum computing in this panel, which I will not handle at this moment, but those are some of the things that generally we say we can do with the quantum on location. Next, please, Chris. And that's basically the quick overview that I wanted to give everybody a chance to talk. And we're international. We're both in Germany, as has been mentioned, and in the United States. And yeah, I'm going to be happy to take part in the panel. Thank you very much for that introduction.
Great. Thank you, Chris. I'm hoping we get a chance during the questions that we've put together to talk about quantum repeaters, right? Not to get granular, but that's a very, very interesting and challenging and potentially hugely impactful application, if you will, right? So
yes,
please keep that in the back of your mind as we get into this panel conversation. So thank you very much. Chris Fregly, I'd like to turn it over to you and have you share what you're doing at AWS and again, your perspective a little bit about AI and quantum in that setting. All right, so let me go up
Yeah.
here. Find this. I'm going to stop sharing this and go share this. There you are. Okay. All right, Chris, take it away.
Yeah, hi there, everyone. This is Chris Fregly. So I've been with the Amazon Web Services since last year. Before that was Netflix and Databricks and part of the original streaming team. I've been doing AI and ML for most of this past decade. So got a lot of good experience there. The quantum stuff is relatively new to me, so I'm going to be probably 60% participant, or sort of read only, and I can contribute where I can. But I actually just did a talk on the Amazon bracket service about 1.5, 2 hours before this. So
Wow.
some of you might have seen that. I posted the link in the chat as well too, so that's got the full rundown.
Cool.
But yeah, basically our bracket service, really kind of started out of our cryptography group. Amazon had been hiring people to take a look at the eventual, post-quantum cryptography. And out of that, we realized, because we were integrating with other services like the Rigetti, like IonQ and D-Wave, that we could actually package this up and then offer it to the public through the Amazon Web Services suite. So, really our whole goal is to make this stuff accessible and create the kind of classic Jeff Bezos flywheel, the Amazon flywheel, making this cheaper, letting people start to gain IP, start to learn the programming constructs, and not be locked into any single provider, but really be able to try out the different services. So, and of course, integrates with Amazon S3 and the Amazon IAM security model and all that. So yeah, that's where I come from. I've got customer use cases I could share that are public and can talk a little bit more about that. But yeah, we have a good group here. I'm pretty excited to hear what everyone has to say. What were the other slides there, Chris? Yeah, I had sent you 3, I think. And you might be on mute. Oh yeah. So I have a book here, Data Science on the Amazon Web Services. This will be coming out early of next year. So we're waiting for the big reInvent conference at the end of this year, I think December. And then once those announcements are made, we'll then release the book after that. So I think the final slide is just, we've got something called the AWS Center for Quantum Computing that is under construction right now. And then also we have the Amazon Quantum Solutions Lab, where we work backwards from your use case and try to map it in if it's a good fit for quantum or if it fits somewhere else in the Amazon SageMaker, the deep learning, machine learning stack. But yeah, I think that particular slide is missing the AWS Center for Quantum Computing, which is partnership with Caltech. I think you're on mute, Chris.
Great. So thank you, Chris. That's exciting. I mean, again, the fact that there's this, I put a link again to Amazon Bracket in the chat, but taking again the infrastructure you guys have, the processes, and leveraging them to support quantum in a real world setting at that scale is pretty exciting, I'd say, right? So cool. So moving on to our professor, let's bring in the academic perspective. Terrill, I want to turn it over to you. Tell us about what's going on in beautiful downtown Harrisburg. All right.
Nothing right now, Chris. There's nothing going on here at all.
Really, huh? Given the
glad to have, no protests at the state capitol this week, but just glad to be here this evening. So I'd like to say hello to everybody and give a warm greetings from Harrisburg, Pennsylvania. And those of you who don't know where we are about a 4-hour drive almost due west of of New York City to a large degree. So next slide there, Chris.
Okay.
A little bit about me. I've been writing software since 1974. So for this discussion, I'm coming from the computer science, more so the applied computer science side of the house. But I started out in industry and financial services. And somewhere around 2000, if any of you remember those great years there, I started to start thinking about an academic career. So I started to ramp up my educational toolkit. Recently, over the past decade, I was at the business school at Peking University in Shenzhen. So some of you tech people can appreciate what that means, Shenzhen in China. But now, over the past 2 years, I've been at Harrisburg University, where magically around 20 months ago, quantum computing found me. And I haven't looked back since. So what I've been doing over the past 2 years is focusing in on quantum computing, trying to develop the capabilities here at our relatively small and unknown university. And at a more macro level, I'm focused, as well as trying to get the university to focus as a whole on developing the quantum computing workforce. I consider the workforce issue probably the number 3 big task that needs to be resolved before quantum becomes available everywhere, other than through AWS. We need people to understand how to use that in the bracket service. So that's our passion right now, is developing workforce programs, whatever that means. Sometimes it means grassroots things like running websites that list all the free events going on, to teaching high school students. I'm proud to announce just this afternoon, I got approval for our very first quantum computing course at the PhD level here at the university. So it doesn't quite get up there with Cambridge computing and IBM's announcement, but for us, for me, it's a big deal. But anyway, next slide, Chris. So, but I've been trained in artificial intelligence at Carnegie Mellon in the School of Computer Science, and so many of you probably know that's a hot spot. I started somewhere around 2004, 2005 on that journey. AI and machine learning has not necessarily been my specialty. But as Roger Daltrey says in a song, I was in that scene. So I had some really world-class professors teach me some of the fundamentals of machine learning, etc. But since we're in a community that likes to classify things and use support vector machines, politically, the question is, am I red or blue? And I'm actually somewhere in between. And what I mean is, there's quite a bit of debate. Not necessarily in the quantum industry, but a broader debate. Are quantum computers a real thing? Will they be useful? Are they now? What could I do with them, etc.? And so what I threw out tonight, this afternoon, I'd like to let you know in advance. I'm coming from the position that I think, and I hope you will be thinking along this line tonight, that quantum computing really has a huge amount of potential, and that potential deserves a lot of respect. And out of this last 3 days, this last session of the last day, I'd like to encourage you AI folks to take some time, do some learning, watch a bracket video fresh off the press. You got 3 quantum computers available on Amazon right now, and it's quite inexpensive to play with. But I encourage people and call out for you AI people, AI folks, AI experts, etc., to give AI quantum a try. There's a lot of potential there. There's a lot of people working on the machine learning aspects of it. Not so much, the broader AI. But I encourage everyone, hopefully after tonight, to do a little digging and explore quantum, because I think if I were an AI person, I think you're going to, over time, find some real rich tools that work extremely well, I believe, if we get enough people working on it. So that's it for me, Chris. Thank you. Mute, Chris. We got to leave you with an open. We got to leave you with an open mic.
Well, I have a very noisy keyboard, so I mute it when I'm typing, but I got to get a quieter keyboard, I think is the key. Anyway, I'd be remiss if I didn't post into the chat the Quantumapalooza link. You kind of referred to it tangentially, but it's a fantastic resource. I encourage everyone in the session here to check it out. It's an free online compilation, if you will, of quantum learning resources, all kinds of stuff. And Terrill and team keep it up to date and spend a lot of time, focused on collecting and sharing this information. So I encourage you all to take a look. It's very cool. All right, so let me stop sharing and let's go to some questions that we put together, right, to pose to you guys. And the segue, really, you kind of set us up. Terrill, I actually want to pose this first to Denise, but it's like, let's start at a meta level. Like, what are some of the misconceptions about quantum? I remember in our prep call, we were saying, people said 5 years ago, well, it's 5 years away. And now they're saying today, well, it's 5 years away. And I think to be sure, it's like, the William Gibson quote, the future is already here. It's just not evenly distributed. I think that certainly can be applied to quantum. But Denise, I'd like to start with you and then have the others sort of weigh in. Like, what do you think? Are we there? When is quantum supremacy a real thing? Quantum advantage, quantum volume? What are we going to really use this stuff? Oh, wait, now you're on mute.
Thank you. Anybody that
Well,
quotes William Gibson is a fan. I'm a fan. So thank you for that quote. If you guys haven't read William Gibson, great author, a futurist. So where are we with quantum computing is always a good question. And when I'm on panels and I go to conferences, there's a lot of different opinions. I spoke to a journalist this morning who told me it was 15 years away. And it's funny because I've been in this industry probably for, oh God, longer than 5 years. And ever since I started, everybody said it's 5 to 10 years away. And that number doesn't seem to change.
really?
So it's kind of a funny thing. So what I do want to say is I think quantum is coming much more quickly than 5 to 10 years. This week we saw an announcement by IBM of a very aggressive roadmap of 1,000 qubits over the next 2 or 3 years.
Right, that was
Honeywell,
pretty ambitious, right?
Yeah, it's very ambitious. Honeywell has a roadmap that they promise a 10x improvement in quantum volume every year over the next 5 years. So if you guys haven't checked out the Honeywell ion trap device, so IBM is superconducting, Honeywell is ion trap. And then we have BraneCell, Chris, our good friend who's awake, doing photonic quantum computing, which shows a lot of promise, room temperature, and photonics is very fast. And so I'm trying to relate some of this to AI. And when you think about AI, you're doing hundreds and thousands of shots on a computer, so speed is very important. So when I look at AI, I think about what technology is going to be able to deliver you the ability to do a lot of shots, but also, or passes, but also what's the noise like. And so all I really want to say is quantum computing is coming. There are some very aggressive and strong roadmaps, and all of you need to get involved now and not say it's 5 to 10 years away and I'll get there when it comes, because it will pass you by. So please take a look at this. Please learn more about it. And I thank you all for joining this session to learn more about quantum.
Yeah. Other panelists want to weigh in? Chris P., you want to give us your sense? I mean, again, the fact that you showed a picture of a refinery sort of speaks volumes, right? I mean, it's on some level.
Yes. Well, I agree with what Denise is saying. It's just spot on. And but the reason why we show the refinery is because we think it's important to talk about applications which work with the client's profit center and not the R&D all the time as the main topic matter. And that's why we have that focus. And, you know, there's several sources of funding, and one of them is just clients paying for you to solve their problems and getting revenue and profit. So it doesn't always have to be grants or venture capital. So we have to mine all of those to bring everything forward. And then we're going to show the world why we need this, because you need to solve real problems, show business cases, and then everybody knows, oh yeah, that's why we should be investing it. That's why we should be focusing on it.
Right.
Yep.
Yeah. So let's go from the meta level to sort of more like right into the granular. And Denise, you kind of referred to it in your answer, but thinking about, and this is for AI, people who may or may not be familiar with some of the nuances of quantum computing, but one of the questions we wanted to pose is, you know, which quantum technology, and particularly say qubit technology, do you think is best for leveraging AI and machine learning? Like, is it going to be superconducting? Is it photons? Is it trapped ion?
So, you know, that's always the question, is there's many different ways to build a quantum computer. And right now, each way has its own strength and its own weakness. So when we look at superconducting, that's probably the most advanced, but it's also very noisy. And noise obviously isn't good. We look at a trapped ion computer like one from Honeywell, and that's a slower computer, but the noise is really not there. So it's a very beautiful computer to run on, simply because of the absence of noise. Now, if we extend out and we look at a photonic computer, inherently very fast, inherently shouldn't have much noise. And I think Chris can talk about that. Chris P. We're on a panel of Chris's. So Chris P.
Yeah.
can talk about that a little bit more. So when I look at the promise of photonic quantum computing, both for speed and not a lot of noise, I think it looks like a very promising computer for machine learning. That's not to say the other ones won't work, but everything has its strength and weakness. Although if we had to choose today, probably photonic wouldn't enter as much into the equation, but maybe Chris, you want to address where photonic is today and where you see it going.
Well, as you probably heard about in the DARPA's program, where they have the ONISC to optimize with a noise intermediate computers, quantum computers. They do look at Rydberg systems, so that's in a way a photonic system. But I think the system that Denise is referring to is another kind of photonic system, and you know, there's a lot of proponents of that. I think Xanadu is one. But I don't know if I should be the one to talk about this, because yes, I know about it, but on the other hand, that's would be favoritism towards my own company. It's a small community, everybody knows each other, and we don't want to be saying things that comes across in the wrong way. But you know, what I want to emphasize is that in photonic quantum computing, photons are the best things to be sending through the telecom O-band, and so you're going to have quantum repeaters, which will get you to the cloud to be able to do things even with regular AI today. What we can do in classical AI or classical computers that run AI in the cloud, and maybe use homomorphic processing in the cloud, so that we would be able to have, you know, sort of end-to-end, highly secure through quantum repeaters into the cloud and homomorphic processing. So there's many ways to solve these problems. And I just like photonic because this seamless connection between the fast processor and another processor bridged by the repeater.
Cool. So let's shift gears for a second, talk about, again, my reference to the picture of the refinery, but maybe Chris P. We got 3 Chris's, no waiting here, right? We got Chris's lined up. Chris Fregly, from an AWS perspective, and I'd like Denise to weigh in too. So how are real world customers using AI and quantum today? Can you just speak sort of, broadly around maybe verticals and disciplines where you're getting traction at Amazon?
Yeah. Do you mind if I share the screen?
No, please. Let's see, I think I can give you,
Yeah, I got it.
you got it? All right, cool.
Yeah.
Yeah. Great.
Yeah, sometimes Zoom lets you grab it, sometimes it doesn't.
Yeah.
Can you guys see my screen?
Yeah.
All right.
Qubits needed for
Yeah.
use cases? Cool.
Yeah, let me grab a couple here. It's probably just on it, but okay. So let me get right to the specific ones. Those are the kind of classic industries a lot of folks talk about here. But yeah, concretely, we have been working with Fidelity to do options pricing, synthetic security simulations, simulating markets, figuring out, which securities can be grouped together, tracking specific indexes. And yeah, they have some quotes here. Basically, they really like the different quantum backends and the ability, to tie into their existing AWS workflows. We got Volkswagen here, public reference. So yeah, same kind of thing, standard programming interface. We have a pip install, bracket SDK is what it's called. Yeah, I think it's pip install Amazon-bracket-SDK. And we got two more here. We got Amgen. So yeah, doing quite a bit of biotech drug discovery type work here. Same kind of benefits. And then Q & Co. So these folks, trying to integrate classic like algorithms, quantum hardware, so quantum hybrid like type scenarios where the CPU is actually coordinating, and then treating the QPUs just like you would treat a GPU, where you've got small little bursts of like massively parallel processing happening, and then so similar to how GPUs work, where you would pass the GPU the data.
Yeah.
Here we're putting that data in superposition and then manipulating the phases and doing all the fun stuff. So those are the three big ones.
Wow.
Denise, how about you?
So that's impressive. Yeah, Denise, you want to share, what's going on?
Sure. And
Just
unfortunately, many of our customers don't want to be called out.
Yeah.
So
maybe you can white label them, anonymize them, a large bank or whatever.
we are working a perfect segue with a large bank, and we're doing Monte Carlo simulations. We're using machine learning. We're using quantum random numbers on the Monte Carlo. So that is something that is a project that we have ongoing. We're also doing a lot of probabilistic machine learning. So where we get results out kind of in a probability type scenario, and we're using it for decision support systems. So a lot of it is for like medical sciences to try to say, we recommend this treatment or we think this with this probability. So that is another group of projects that we're doing. What we have is a very creative team, and as people bring us problems, we address them. So I'm giving you a flavor of two of the problems that we're looking at. I also want to talk a little bit, we do quantum neurolinguistic programming, which is also machine learning / AI. And we actually have done the first quantum experiment on an IBM quantum computer. And NLP, our NLP research is still a couple years out. I won't say 5 to 10 years out as a joke, but it's a couple years out. But we feel that we have the technology and the know-how and the team led by Bob Cook from Oxford to do sentence recognition, where Siri looks at words. Bob is already starting to look at sentences and context. So a lot of really great potential for AI, kind of what Chris is showing and what we're doing shows that there's potential to make an impact by using a quantum computer in AI.
Yeah, no, that's great. Thank you. in terms of like, we're going to need people to know how to do this stuff, right? So Chris Fregly has books. He's written, he's got that book coming out soon. That's exciting. So the implication is we need a workforce that knows how to do this stuff. So Terrill, as the professor, as the resident academic, can you give us a sense of like what kind of skills people are going to need to be successful in the quantum/AI space, right? And
Well,
probably
Frank,
more than just like physics, right? As Denise was saying before, right? It's more complex than that. Not to say that that's not complex, but
yeah, I think first of all, let me just say that in my opinion, broadly, an individual who has the skills to fully understand AI and machine learning techniques and the abstraction associated with that, how neural networks work and all that kind of good stuff. As I said, SVMs and classifiers and that kind of mathematical background and ability to understand abstraction, I think would fit very well with the quantum world, in the quantum computing world. So they've got the raw intellectual capability. So I think that the hard part has already been accomplished by those individuals. There'll be some fine tuning, linear algebra and that sort of thing. The mathematical aspects should be quite straightforward. There's a tendency for people to want to get into the physics of it. And personally, I think it's unnecessary to really know the physics, just like it's unnecessary to know how, the electronics in your laptop works.
right.
You can still be an excellent developer without knowing that. And because we're early in the industry, in the innovation life cycle here, we spend a lot of time talking to physics, but personally, I don't think it's really necessary for an AI person to spend much time in the physics or the engineering of it, quite frankly. To the credit, and a big shout out and thanks to the companies that are out there that are, removing us, in the stack away from the hardware, so that we can focus in on AI problems. So for example, Google has a Tensor Quantum product that removes you from the hardware. So I think if you're an AI capable individual, you pretty much just need to do a little adjusting of the dial, if you will, which should be just fine. So I think the AI is set up quite well for it.
Yeah, well, I like the idea too that sort of abstraction at a meta level, being able to kind of see, across disciplines and connect dots in new ways. So yeah,
it's a different paradigm in how we compute, and that's a little struggle if you've been a classical developer like me for a long time. It's like going from the old go-to statement to object-oriented programming. It's what's the word I'm looking for? It's just quite different. The paradigm is quite different. But once you get over that, I think there's some exciting stuff to come from the AI community.
Cool. Well,
Hey,
thank you.
Terrill, we have a question on what's a good getting started guide. So I'll jump in and ask you what you would do to get started.
Yeah.
Go to Quantumapalooza and start attending events.
Yeah.
But they're probably immediate, simple question, and simple answer. I'd go to YouTube. There's a machine learning or a quantum AI channel out there that's very good. And I think an AI person will just suck that information in, quite frankly.
Cool.
There's so much material out there. It's available.
Hey, Terrill. So I posted the link for Quantumapalooza. Can we actually register to get notified? Is there like an RSS feed or something, or do I gotta keep going
if you're an individual one I don't have a public RSS feed. I have it private right now, but I'll probably open it up for an RSS feed.
Okay. Or like an email
problem,
list.
I don't want to go. There's 3.6 events per day, and some days
Yeah.
the high water mark right now is over 2 days. We had 13 and 12 events, so 25 events in 2 days.
Great.
All independent. It's not like it was a big conference.
Right, right.
So I think I'll stay away from the email list, but I may work that in because, you know, I could do the Windows notifications and stuff like that. But yeah, I'll probably have an RSS feed out sooner than later.
Okay. For those of you that are time zone challenged like me and always trying to look at, oh, this is at 3 p.m. in Berlin, what time is it in the Pacific time zone? The secret is right under the header, there's a little white box, and you can put your time zone in that white box, and then magically all of the talks show up in your time zone, and you can see what time they happen, and it's really helped someone like me make sure that I can attend talks. So thank you, Terrill.
My pleasure. Can I share this? Can I share the screen for 1 minute?
Yes, please.
All right. Because I know everybody, you know, what is Denise talking about?
Right. Yeah. No, please.
But I don't.
Can you
I don't want to. Yeah, I don't want to digress too much. But this
no, it's good. This is all good, man.
This is if you want to learn about quantum, I think you can see it right here, right?
Yeah, I can see it.
And this is a little baby where we change the time zone and stuff.
Cool.
Particularly if you're in India, you know, it's the
5.5
half-hour thingamajiggy. But getting back, so the point is that there's 127 events on the schedule going forward right now. There's tons of them, and you know, just you do a Control F and you do AI or something like that, and we should there should be a couple out there. There's 172 hits, but I don't think that's exactly what we're looking for. But yeah, I'm proud of the resource. I keep it up to date about 3 or 4 times a day.
Page down just a little bit. Next week is my company, Cambridge Quantum Computing, or the company I work for, is having an event called the Quantum Week of Fun, which is right here in green.
Cool.
And it's just a great event for you to start learning about quantum and seeing some of the latest science. So we're looking at quantum algorithms, we're looking at natural language processing. Just a great event. If you guys want to do that, again, free, virtual, all those good things.
Yeah, very
so that
cool.
might be a starting point if you have some time next week.
Yeah, I forgot about that. Yeah, it's got the NLP. So I guess Bob will be talking at that among others.
Exactly.
Really? Oh, great. Very cool.
Oh, thanks.
So that's great. Yeah, Terrill, thanks for sharing that. Again, I'm a fan. I think it's an amazing resource for sure. So mindful of the time, I'd asked each of these distinguished panelists to come up with someone, a person that they thought was, look at my notes here, was kind of a leading thinker or evangelist or influencer in this space, sort of at the intersection of AI and quantum. So I want to ask each of them to share a name and maybe just a little bit about who that person is. And I have some links I prepared that I'm going to pop into the chat as well. So Denise, you want to go first?
Sure, and I've already mentioned my person. His name is Bob Cook. He's, or C-O-E-C-K-E. He's from Oxford University.
Yeah.
Just a tremendously bright, charming, talented man who's working on quantum NLP and has done a lot of innovation in the area of quantum and quantum programming. If you guys get a chance, he does these podcasts from his pub at home where he has a cardboard box labeled quantum computer and 2 skeletons with hats on it as his audience. And he's just a tremendously creative guy, but has a gift of being able to tell you something very complicated in a very simple way. So he doesn't just blow you out of the water. He can talk to you and really talk you through some advanced concepts. So I love him because he's a unique and fun individual, smart, and the best thing is he's a great teacher on something very complex. So look him up and watch a video.
Cool. Yes, I put his, just so everyone knows, I put his Wikipedia URL in the chat client. So what's the
Thank you.
name of his podcast, do you know, or is
I don't know if he has a name. If you
this
follow
Bob's
me on LinkedIn,
podcast?
whenever Bob does a podcast, I post it because I just love his skeletons. He always comes up with something new in the pub. So
Cool.
watch me on LinkedIn or
Yeah.
just Google Bob Cook on YouTube and you'll find a lot of material.
Great, thank you. Terrill, who would you suggest for these people to check out?
I feel like I'm in one of those talent shows, being one of
Exactly.
the judges here. So I'm going to put my vote on Maria Schuld, and I'll share real quick.
Okay. Yeah, put in the chat.
Because she's got more publications than probably anybody. Can you see this here? She's
Yeah.
right
Yeah.
there. Maria is, as far as I know, can you see it now still?
Yeah.
Okay. As far as I know, she's full-time at Xanadu, which is one of the hardware companies in the quantum space, but she's based down in South Africa. But to give you a sense of her vocabulary and where her mind is, I listed out some of the pubs that she's put out over the past 3 or 4 years.
Yeah.
So, and on the bottom left there, you can see the number of citations this woman has earned. And so she gets my 5 stars
Cool.
for the evening, that if you want to learn about quantum computing, in particularly the machine learning space, you know, your basic classifiers and pattern recognition, etc. She's a go-to.
So I thank you very much, Terrill. I put her LinkedIn profile link in the chat, as well as I found a Google Scholar link where a lot of those publications and many, many more are listed. So anyway, again, for our listeners. Who's next? Chris P., do you want to go? Are you still with us?
Sure. I'm still with you. You're doing a great job, Chris. I haven't fallen asleep.
Oh, thanks.
Yeah, sure. I'm gonna do 2 things here. First of all, I want to mention to everyone listening that there's a very great paper, 2018, on quantum machine learning, where one of the co-authors is Seth Lloyd, and he does an outstanding job in the quantum technology field. And some of the co-authors, one of the co-authors is from the Max Planck Institute for Quantum Optics. So I'm going to take it in a little bit in a German direction, because here we're more about teams than stars. Yeah, genau. So I want to mention the
Lloyd's link in the chat again.
Yeah, thank you. Wonderful. And that paper people can get to. But I just mentioned the group. There's the group being, well, Max Planck has a couple of groups on quantum science and technology and quantum optics. And if you go to the quantum science and technology group, for example, you see several outstanding papers in 2020, all kinds of contributors from many different countries, different European countries, so not just German. So you'll see a wide variety of, you know, great work there. So just I guess an American way of saying a shout out to the International Max Planck Research School.
Great. Okay. Thank you. Yeah.
Welcome.
So Denise, I saw you put I actually signed up for the Women in Quantum event. So again, in an effort to achieve gender parity, and I'm a big fan of this, it's important in all seriousness that we get more women involved in this space, right? Do you have the URL for that? Shall I look it up and paste it in here?
I'll paste it in the chat.
Yeah, please do. It looks to be a really cool event. And again, Maria, who Terrill was touting, is going to be participating. So Chris Fregly, is there someone you want to call out for this group?
Yeah, you know, I'm not as well versed on the academic side of things, so let me share my screen here and tell you what I've been doing.
Whoa.
So yeah,
wow.
true to my employer, I have I've finished Netflix, by the way, because of COVID times. I've completely finished
It's
Netflix.
Netflix. Select
There's
all.
nothing left. So I
Really?
switched over to Prime Video. And this guy, Jim Al-Khalili, yeah, I like his style. I have no idea, who he is from an academic standpoint, but he's got a cool accent, cool British accent.
Huh.
And his presentation on quantum sort of theories is, very engaging. It's, for more kind of non-academic. One thing I found about quantum, and it's not about AI, ML, it's more just kind of quantum theory, but, he kind of shows it in sort of common person speak, right? Because one thing I've noticed, like when I was starting to learn about quantum, is very quickly things end up down the physics route. And while I love physics, it's not my day-to-day. And I feel, kind of back to, I think, Terrill's point, where, if we can present these things in a little bit softer fashion, or more maybe application-focused fashion, or higher level constructs, I think that, similar to deep learning, right? Like, we didn't really have, well, it certainly helps, obviously, to know the linear algebra and to understand the calculus behind it. But I think there's, ways to present these things. So,
so that's
my
great.
vote is Prime Video.
Wow. And these, boy, there's a lot of these, huh? Cool.
Yeah, this is actually just, if you search Jim, but if you search, this one's pretty good here. And some of this is more sort of introductory stuff, but then very quickly we get recommended Star Trek and other things.
It bleeds over into, well, that's cool. Well, great. Well, thank you for sharing that. Mindful of the time, there is a question. If anyone has questions, please put them in the either Q&A or chat. I do see one person, they describe it as a novice question, although it doesn't sound novice to me. It says, I have a novice question. Are qubits arranged as a matrix NXM? Can qubits be daisy chained where the output of one qubit is an input to another without collapsing the wave equation? Any panelists want to take that?
That's a beginner's question.
Boy,
I'm just saying that to be funny.
Yeah.
Well, here's one thing, where the hardware matters. So, they're not being an engineer, but there's a constraint where every qubit cannot be connected to every other qubit. Although in some hardwares, there's a company IonQ available on AWS bracket that does have every qubit connected to every other qubit. So that is a fundamental difference between some of the hardware modalities out there.
Great. Well, thank you, Terrill. And Jamie, does that answer your question? I hope it does. No? We have like 3 minutes left. I don't see any other questions, but I think it's been a great conversation. I want to thank all the panelists for participating. I think it's been a great learning experience. And again, there's a lot of, there's links to a lot of very interesting information in the chat. Please take a look, please save it, or do a screen grab or whatever you need to do. I would also encourage you to connect on LinkedIn. I'm speaking for the panelists, but I'm a huge fan of using LinkedIn as a tool to foster connection and collaboration, especially since we're kind of in the early days. We're at least 5 years away from real quantum computing. No, just kidding. But feel free to reach for me on LinkedIn. I'd be happy to connect with any and all of you and continue this conversation. So KRS, we turn it back to you.
Yeah, Christopher, just I appeared. I have been listening to all your amazing comments, amazing in the subject. I really love, like all of you. And Christopher, you brought the best out of the people, asking the right question at the right time, and so on. I really appreciate. And Denise, thank you a lot. I know a lot of your colleagues, Mark Jackson, I routinely communicate with, and including the founders, you know the names, I don't have to. They are IBM connected, etc. So very good. Thank you a lot for your insights and so on.
Well,
and then you are taking chief strategic role now. That's also a good one. Thank you for that. Chris Fregly, you've written books and so on, and you talk about variety of, he is a routine speaker in our conference, very good presentation. Professor Frantz, very nice. Harrisburg, I know very well. I used to visit I was in AT&T Bell Labs, managing some of the who's in R&D there. And I used to come there. I have some colleagues we can talk offline in Harrisburg. And congratulations on your academic position there and research position that you have. Chris, I know he's going back to sleep and coming back. I understand, that's totally okay. And sorry, I didn't mean to wake you up, but I wanted to thank you. That's what it is. You need to be thanked more than anyone else, You are in a different country, different world, different time zones, right? And I thought I'm the only guy who's going to do all this all night, all day, because I have no life, no one in my life. So you are a family man, I presume. Thank you a lot. I am really energized, and I'm doing a full day conference, as I mentioned. We've already signed up who's in the field, and IEEE being truly, kosher technology guys, right? Compared to both technology and business, who I am, I liked your panel, and then you're all welcome to contact me. I'll put in the chat my contact details.
Yes,
it's simply bigdataexpert@gmail.com, and we should continue on quantum computing thing. Just want to talk about before we close, we still have a minute or so, for you to think about epidemiology and virology, where multiple dimensions are there, how the virology works and epidemiology works. Anytime there are many dimensions, quantum computing is ideal, because you cannot do it by regular computing, right? That's one of the things. I'm just giving one example. Weather patterns, again, it's many dimensions that are involved, and parameters plus dimensions. So think of those things where applications are, as you were talking about applications. We're going to cover that. I'm going to do a series of webinars just on computing, and I'll be glad to share with you. And I'm going to go into more fundamentals of why it is quantum, and what is really quantum more than what the scientists think, because I've written about it. Thank you a lot. Appreciate it. We had a great session. We are finishing with a big bang, quantum computing. The future.
Well,
thank you a lot.
Thank you, Harris.
Thank you.
Yeah,
Thank you, Chris Fisher.
Great.
Okay, we'll invite you back.